OBO construct, a PV mounting system for flat roof or pitched roof installation planning. How does it work? OBO construct provides a user-friendly tool where we can quickly enter the address details, including the street, house number, and postal code. It checks to confirm if there's an active, valid address available, and then promptly suggests it right below here. I can select it. Naturally, the house number is missing at this stage, so I'll add it here once again, and then proceed to select the entire thing once more. With that, I confirm the correct address, and here I now also locate my building where I'm planning to install the PV system for solar energy. In the next step, all geodata referenced information is now being automatically loaded into this section. Here's wind zone 1 and snow zone 2 in my example. These will later be needed for the structural calculations as well. In the second step, I now also need the terrain category that applies to my building here to properly factor in the varying wind conditions that are relevant here accordingly. By zooming in and out of the map, I can carefully assess and determine which category would be most suitable in this case. In this case, it's now category 3. I choose this option, confirm the selection, and proceed to move forward to the next step ahead. In the next step, we have the roof configuration here. We offer 3 roof types: flat roof, shed roof, and gable roof. For each roof type, there is a so-called visual sketch here that helps us to clearly identify and locate the corresponding input fields within the image, ensuring that I can accurately and correctly make the necessary entries with precision. Let me provide an example for a flat roof. In the case of the flat roof example, I will select the cover type bitumen for it. Here, a friction coefficient is already taken into account by default. For a flat roof, it is particularly important before installation to determine a friction coefficient using a testing procedure. For that purpose, we have a separate report available to ensure we can accurately create the protocol. The value that was determined through the inspection protocol is then entered right here. This means the statics here will essentially have to be recalculated. In my case, I'll now take the standard value. I just want to do a quick planning session for now and can always go back and re-enter the value later if it turns out to be necessary for the statics at that point. The roof name can be selected separately. It has to be entered individually. That would now be South Roof Bungalow here. I've got a roof length of 25 meters, a roof width of 17.50 meters. The building itself stands 6 meters tall, and the slope has been precisely adjusted to exactly 2 degrees. A parapet is present, though not in my case, but I can still enter it here if necessary. I can enter the height and width of the parapet here, and this information will then be appropriately taken into account in the next planning level. During the selection process of the assembly options, in the next step, the mounting systems are now available for selection here. Here we have the mounting systems, our flat basic system, where we can work directly on the roof using a flat rail, or we use our flat pro system, which allows us to work with a slight elevation, where the cable management systems could potentially be installed beneath the PV array, providing a cleaner and more organized setup overall. But today I'm going for the Magic PV Flat Basic. Let's now move on to the product selection. Here I need to once again confirm the selection accordingly. The pre-selection in the Flat Basic is planned here for ballast absorption with a mesh cable tray GRM 55 30-100 feet. However, I can also individually choose a different one now or later on. By going back, I can easily return to this menu and swap out the mesh cable tray if needed. The barrier strip is an optional feature, designed to assist in neatly organizing and separating cables, where you could easily select the barrier strip in this menu. For mounting the universal clamps, the question here is whether to choose black or silver ones for this setup. For a black line, I'd definitely opt for black clamps. If the PV system is neutral, then silver would also work well. The function is identical for both. Don't forget the earthing terminal, as it's crucial for the equipotential bonding, so that it can be integrated into the building. The next step is now to define the obstacles or the interference areas. When I click on Add New Obstacle, a small box appears up here. I can move it around by dragging and dropping with the mouse, resize it, make it bigger or smaller. I can also copy it multiple times. Let me give you an example here. Let's say we're designing and creating a skylight for the roof. And let's name this window number 1. That I can then copy and place anew. That would then be window 2. And this up here, let's take that as the air conditioner. Here's a concise list of my 3 primary challenges or areas of difficulty, and could now take the opportunity to dive straight into the obstacle itself to continue addressing and thoroughly working through it in greater detail. Other disruptive areas or maintenance pathways can, of course, also be positioned accordingly. That would essentially be the same use of an interfering surface, which I would then accordingly place in the exact location where it is required for optimal functionality. You can see here that the continue button is not yet orange. It's still grayed out. We're here in this step. It's still not finished. That was just the obstacle configuration for now. The next step would be to select this option here at the top, specifically the mounting for the modules. We have a database here that we are now opening, containing 45,000 modules and manufacturers, and we can enter a partial term here at the top using a kind of wildcard search, which will then display the corresponding results in the search up here, showing the relevant matches instantly, lists them. By highlighting this pin in orange, I can mark a module as a favorite, and these favorites are then, let me show it once more, also accessible within the standard search results. I've already marked quite a few here, and they're always displayed at the top of the search results. When I use the planning tool more frequently, I have my 4 or 5 favorites that are consistently pinned at the very top. I would now select my Tiger Pro from my favorites list. And by confirming the selection, the OBO construction will now extend across the entire roof as far as possible, including setback. So considering roof clearances and obstacle distances, the module field will now arrange itself here to be displayed at its maximum possible capacity, ensuring optimal placement, efficiency, and full coverage. I can, of course, also manually adjust this period, or even change the orientation. Currently, it is always initiated in the east-west orientation by default. However, I can quickly switch it to a south orientation, and by using the mouse over function, I can now clearly recognize that these orange circled rows or areas create distinct separations between the individual module fields displayed on the screen. Because here, a thermal separation is necessary, since the total length of this rail, which is built and used here, needs to be separated after approximately 20 meters, where a second segment then forms. And this, from a static perspective, will also need to be carefully considered individually in the later stages of the process. We'll soon observe how the small field compared to the large one. And I'll repeat it in east-west orientation. The small field tends to be less efficient in terms of ballast distribution because the interconnected components in a large field system are better positioned for distributing the loads, ensuring greater balance and efficiency overall. And that's exactly what we'll now proceed to in the next step, where we'll observe how the static analysis is being calculated for this specific setup. And here we now see the static report or the summary report. And you can see that this small section, section 2, would need to carry a relatively high load because it is naturally being evaluated independently as well. This means it has to handle the weight on its own. The entire load-bearing structure is the roof itself, but since its span exceeds 20 meters, it must be separated in this particular section here. Accordingly, this small section here is depicted, quote unquote, as slightly less favorable due to its specific structural constraints. Then I can correct it again if I wish to. Otherwise, I'll receive here all the detailed partial information for module field 1. This is area 1, the large field where we can observe these gray stripes right here. These are the grid channels I've chosen. The mesh cable tray, GRM 55-300 feet in this case. And here we can see that the large field would only need to be ballasted at this one corner. Otherwise, the grid trough is entirely sufficient to provide additional structural rigidity to the entire system. And the dead load, including the modules, is entirely sufficient to effectively counteract any potential shifting or uplift in this area. The seemingly smaller field is accordingly less favorable, requiring multiple instances of ballasting in this individual consideration here. To effectively address this specific problem, I could revisit the earlier step and, for instance, reduce the size of the module field by roughly half, thereby optimizing its efficiency. That might be a bit inconvenient, but I can always just go ahead and copy it again later on. Roughly. 2 equally sized fields. That means here I have 64 modules, and in this one I also have 64 modules. East-west, by the way, is always laid out in a few ways. I can also select these by clicking with the mouse cursor. Accordingly, the substructure is also calculated. In this case, I would probably now have an unfavorable representation again. But we'll see. I'll recalculate the statics. Now, of course, I get 2 individual fields, relatively equal in size, and in this area, I now have the layout so favorable that the assisting surrounding components here are sufficient to manage the load effectively and efficiently without any additional support needed. To implement the corresponding countermeasures, specifically in the form of ballasting right here, to present it relatively cost-effectively, here I need relatively little weight due to the self-weight specification of the complete mounting system, including the module weights. They are broken down again here on the left, how the entire total weight here is composed and broken down in detail. And I can now observe the same once again in the next step within the overall summary view. That means I have my selected products for module area 1 and 2, which are being separated into distinct sections. Here I have the required quantity, and then the corresponding order amounts that I can, of course, also place through the wholesaler as needed for the project. To wrap this all up, I still need up here revenues. Here once again for a quick review. Can I go through all the inputs one more time that I had previously entered earlier? That means inputs for the address, inputs for the roof, the module configuration, the view of the substructure, and the particular module that I have chosen here. And now I can manage the entire process here within this new project. Save it, and then have it ready. For my reuse directly accessible within my dashboard, specifically here under projects. And locate my south bungalow here, and as a result, I have the planning overview displayed once again for quick reference. I have covered the south bungalow with a flat roof type with bitumen, and I have a total output of 42.12 kilowatts peak. I have 2 module areas on the roof. If I unfold this here now, I can see additional information accordingly. Once more, regarding the roof with its elevated length and width, including a total weight specification that directly affects the roof structure. This is very important to relay the information once again for verification by the structural engineer or the architect, as they will need to incorporate this data into their overall structural calculations and detailed analysis. Then I need to verify again. I can also set up each module area individually to gather more details. Here, of course, the Tiger Pro module was used for both systems. I have 48 modules in the first module field. I have a total load per square meter of just under 11 kilos. Here, I can see again the individual items that are to be mounted on this field. And the second field looks quite similar. And here I naturally also have 11 kilos. Approximately 11 kilos per square meter, which then also ensures a very homogeneous distribution across the entire roof. And here, it's highly likely that the possibility of non-installation is effectively ruled out. The whole thing still needs to be reviewed by the expert, as mentioned, or by the architect accordingly. This is simply a digital compilation we've put together here, essentially a material compilation for reference. We are putting everything together here again in what's called a project report. I can then download it accordingly, and it appears as follows. The project here is displayed in green in this instance because the statics have been successfully passed and fully approved. We can proceed with the installation of the system, ensuring it meets the wind and snow load requirements for the specified areas here. Here is once again the detailed overview of the entire project, including the roof structure, the layout of the modules. Once again, here's the cross-sectional view for the installation of the elevated systems, allowing us to clearly identify and precisely reference the distances A, C, A, B in the detailed list provided below, that we can assemble the small and large supports as per the specs here, ensuring everything fits together seamlessly and correctly. Additionally, we've also provided a brief overview of the substructure setup along with the detailed layout of the ballast system. The ballasting, which can then be read accordingly in the blue boxes provided, and of course, not to forget the material list, including our calculation fundamentals as well as our essential legal notes. I can then also send this directly to the wholesaler, forward it to the wholesaler, and proceed to order my materials.